Hello friends, welcome to follow up. Let's have a look at problem 1101, the earliest moment when everyone become friends. In this video, we're going to explain a solution based on UnionFind. And here we're going to use a very simple implementation of UnionFind, right? So because the problem set is not that large, so we don't invoke the find with path compression and union by rec. We just use vanilla ones. So here in this problem, we have n people, right? So we have a logs which contains time, and the two people become friends at this time stamp. So here the second paragraph says that friendship is symmetric and it's also transitive. So our task is to return the earliest time for which every person became acquainted with every other person. If there is no such earliest time, we're going to return -1. So here we have two examples, and in the first example, this is the return. So this number is not easy to look at which one is larger or which one is smaller, right? So meanwhile, it's not assumed that the time is sorted in sorted order. So overall, we need to track the time, and therefore we need to some sort of sorting, right? Sort with the first component. So the first example, the output is this number. So you can look at the explanation. And in the second one, the time is easy to compare, right? 0, 1, 3, 4, 7. This time actually is in sorted order, right? So the return is 3. So when at time 3, every person, all the persons became friends. So before we dive deeper, let's look at the constraints. So we can understand these constraints as additional assumptions. So first, the number of peoples or number of persons is bounded above by 100. So this number is not very large. Secondly, the log has a length bounded above by 10 to the power 4. And the other ones are basically range conditions or consistency assumptions. So here we want to emphasize the last two. So all the values of timestamps are unique. And lastly, all the pairs xi, yi occur at most one time in the input. So with that said, basically we can catch or explain the big idea of the coding we're going to implement. So here we need to first pay attention to the time order. So due to this fact, we need to do a sort for the logs. We just need to sort according to the first component of the logs items. So this is one thing. Another thing is that so knowing each other for all the persons involved, it means that there's only one connected component for the graph. Or we can see the graph concerning this n persons forms a singly connected graph, right? So this is the one. So we can actually track the number of clusters or connected components using UnionFind. So that's why the UnionFind method seems to be very natural for this problem. So with that said, basically let's look at the coding part. So here, as we mentioned, we just need to give a very vanilla implementation of the UnionFind. We don't need its full power. So first, I'm going to sort the logs. So this way, we know we can monitor the earliest time for the persons being friends. So this is one. Another one is that it's actually also a preparation. We want to implement the UnionFind method, but in a very simple way. So as we know, there are n persons already, so we can do this. So we can do a root. Let's use a dictionary. So for I in range n. So I'm not going to initialize a rec dictionary or list because I don't want to use union by rec to accelerate for this problem. And then I'm going to directly implement the find and the union method. So here define a find function. So we are going to find the the root of this person I. So here we can write a recursion solution. So we can return I if root I is itself. Otherwise, so we're going to find its root, right? In other words, we retrieve along the chain above, right? So this finishes the function. Now let's define the union function. Here we accept two persons or two arguments, and then let's first find its root. So there are roots, so find I, find G, right? So if the two roots are the same, we do nothing. Otherwise, we just join the two clusters. So if root I does not equal to root G. So then here I'm going to put root G's root to be root I. So that's it for this implementation. And then we can monitor the process, right? Here, let me specify the detail. Or problem logic. So initially, because there are n persons, so we can see the n clusters. We can initialize as n, right? And then because we have already sorted these logs, so we can do a linear scan. So for this time, this is the two person ig in logs, right? So let's check if they are already in the same cluster. In other words, if find I and find G, if they are the same, in other words, they are already in the same cluster, so we just continue, right? If they are not in the same cluster, so then we're going to join them, right? So this way, the number of clusters is decremented by 1. So we are going to do this, n clusters decremented by 1. And then we are following this decrement by a condition check. So if n clusters equals 1, this means that all the persons know each other. So we just need to return the t, because we have already done a sort. So this time will be the earliest time. So if after the for loop nothing has returned, so we're going to return -1, because the graph will not be singly connected after we finish scanning the logs. So this time, this situation, we're going to return -1. So before we make further comments, let's first do a test. Yeah, it passes the second example, I guess. Now let's look at the generic case. Yeah, it passes all the test cases. So that's basically about it for this specific problem. I guess for this specific problem, it provides us a very use case for practicing union find. So in this video, we implement a union find in a very simple fashion. For example, we didn't use path compression in the find method or function. And also we didn't use union by rack feature in the union function, and due to the problem size. But for this problem, that will be sufficient. However, sometimes you might prefer considering to add path compression, to add union by rack to accelerate the process. So that way, so you are using a full-fledged union find method, or in general we call it disjoint set data structure. And this is the one comment. Another comment is that there are typically two choices of using the union find method. So one is you implement a class outside of the solution, right? Then we initialize the class object. That's one way. So typically that's very general. And here, because we already know the number of persons or the number of nodes in the graph, here we directly implement the two method inside the function here. So this is very quick, right? So that's basically due to the problem size. So with that said, basically that's about it for this video. Thank you.